Good evening and welcome everyone to this, the second in the Jewish Renaissance Lines Learning Project series on Jewish medical ethics. Last week we introduced our topic with the question, because we can, should we? And that question is considered in further depth this week as we engage in a discussion on genetic screening, designer babies. We are capable of diagnosing an increasing number of traits, diseases, and defective genes, but what are we to do with this information? Is knowledge power, or can it, in the words of Rabbi Moshe David Tendler, become a tyranny? Knowledge a tyranny. When there is no known cure and the options for dealing with the knowledge are limited, what is it that we should do? How do we counsel individuals when faced with such devastating news? And what does Judaism tell us as to how we should act? With expanded genetic screening capabilities, there come more complex ethical decisions. And so it is that we are very fortunate to help us grapple with these questions, to have with us tonight an expert on Jewish ethics in this area, and an expert working in the field, counselling those with serious genetic neurological disorders who can tell us of the real life process. We begin with Dr. Daniel Eisenberg, who is an assistant professor of diagnostic imaging at Thomas Jefferson University School of Medicine and a practicing radiologist at the Department of Radiology at the Albert Einstein Medical Center in Philadelphia, where he was a former member of the Hospital Ethics Committee and currently sits on the Institutional Review Board. He is a noted lecturer in Jewish medical ethics, lecturing around the world, including serving as a medical ethics scholar in residence for the New England Institute for Jewish Studies in Jerusalem and for the Schlesinger Institute for Medical Halachic Research. Dr. Eisenberg has published multiple medical ethics articles in both scholarly and lay press, contributing to both secular and Jewish books and periodicals, including over 30 Jewish medical ethics articles for aish.com. And most recently, Dr. Eisenberg has developed the content for the Human Subject Research web-based instructional module in ethics and professionalism for the American Board of Radiology. But just before we go over to him, can I ask you please to remain muted during the talks and to remind you there will be an opportunity for questions later. If you have a question, if you would write it in the chat, and we'll ask you to unmute when your time comes round to ask it. After Dr. Eisenberg, we will meet Dr. Juliette Harris and then end the evening with information about Jnetics and their plans for the future. So let us begin now with Dr. Eisenberg.
All right, I just have to figure out which screen I am sharing. And then we are in business. Okay. Can people see my screen?
Perfect.
Yes. Okay. So I'd like to thank you for inviting me to speak with you today regarding issues that arise in genetic screening and how traditional Judaism deals with these issues. I'd like to preface my remarks a little bit with about genetic screening with an explanation of how the Jewish legal system works. I'm going to briefly explain some basic genetic concepts involving recessive and dominant inherited diseases. And then I'd like to investigate the ethical issues involved in screening between dominant and recessive diseases. But basically, the bulk of today's discussion is really about screening for recessively inherited diseases from a Jewish perspective. This is my website, and this way, since I talk too fast and probably a very funny accent for those who are listening to me today, www.jewishmedicalethics.com is my website, and it has a lot of the articles, and I also have sent a handout, which eventually will be sent to you, with an article about recessive screening and dominant screening and genetic modification and things like that. I also have articles, I didn't know that we were going to talk about that today, on designer babies, CRISPR, things like that. All right, so let's start. The key thing to understand is that good ethics begins with good facts. And second, in the Jewish tradition, ethics and law are inseparable. That is the backbone of Jewish medical ethics. So before we can discuss anything, we've got to discuss the good facts. This is called a karyotype. A karyotype is an individual's collection of chromosomes. The term also refers to a laboratory technique that produces an image of the individual's chromosomes, which is what this is, right? The karyotype is used to look for abnormal numbers or structures of chromosomes. And for any of you who have ever wondered, what's the difference between a boy and a girl, right? You may think you know, but the reality is, that's it. That's the difference between a boy and a girl. That's a girl, that's a boy. There's a Y chromosome, which is shorter than the X chromosome, 2 X chromosomes, and you're a girl, one X chromosome and one Y, and you are a boy, right? The basic idea of the chromosomes are that they contain the patient's DNA. The DNA is made out of multiple base pairs of ribonucleic acids, and the patterns of these, which are just 4 letters of the alphabet, is the simplest way to put it, create genes. And this is probably way too small to see, but you can see that basically the G matches up with the, I think the C and the A with the T, and those are the genes. So each gene codes for a protein, and the protein is basically what makes up your entire body. So this is a very, very basic introduction to genetics. Your cell contains chromosomes. Chromosomes have genes. The genes make proteins. One of the problems is, though, that the genes have to be able to be replicated accurately, and almost all the time they are. And your cells have a mechanism within them to fix errors, but it's not perfect. And so one way to look at it is a slide from the Greenwood Genetics Center. Chromosomes are like encyclopedias. One set is from the mother, one set's from the father. The genes are like the pages that describe what's supposed to happen. The problem is, every once in a while, when the book is copied over, errors occur, called mutations. So either a word is misspelled, which is they've replaced the E here with a D, and the word red becomes ard-d and becomes unreadable, right? Or something just gets dropped. The car was red and the word car got dropped. And there's different kinds of mutations, missense mutations, insertion mutations, deletion mutations, nonsense mutations, which is not our topic. Just understand, though, that when there's a mutation, right, the gene is changed and it may code inaccurately for the protein that needs to be made. If that protein that needs to be made is crucial, that could be the difference between life and death. So to go into some of the good facts about genetics, there's something called genotype and something called phenotype. The genotype are what your genes are. Your phenotype is what you look like, basically. So in this case, a purple flower is the phenotype. And we're going to say the genotype for this, where purple, for argument's sake, is a dominant gene, which we'll talk about, is either big A, and we usually use capital letters for dominant genes, right? And little a is for small, for recessive genes. So as long as there's one big A, it's purple. And in this white flower, which we're going to call recessive, right, it has to have 2 small A's or 2 small recessive genes for white for this to be shown. And I'll explain how this works, right? So let's call, it's actually important to understand, I give a talk like this to a girls' high school here in Philadelphia. And one of the things I explain to the girls is that the idea of judging genes, and this is not going to be a political discussion, but really has to do with what's desirable and what's undesirable. You could argue and say that it's normal to have brown eyes, and that basically you've got a mutation if you have blue eyes, right? That is, the phenotype for blue eyes is small b, which is small blue, gene for blue eyes, and the genotype for brown eyes, which is dominant, is either 1 gene for brown eyes and 1 for blue eyes, or 2 for brown eyes. Now, why do we care about this? Well, we don't really care if someone has blue eyes, and a lot of people probably think it's desirable to have blue eyes. So you would think that the recessive may be desirable. But what happens if the recessive is not so desirable, which is really where we get into the genetic screening? What happens if the recessive is a disease? This is called a punnett square, and it's basically just a simple way, which I'm not going to get into, to predict the probability of different genotypes. So for instance, in this case, where you have two purple flowers, where we said that purple is dominant, right? But in this case, they're what's called heterozygous, which is they each have a gene for purple and a gene for white. But if they have one for purple, one for white, they're going to be purple. So you have two purple flowers that you're going to mix. And in that mixture, you're going to wind up with three purple flowers. However, of these three purple flowers, one of them has two genes for purple and now cannot really ever produce a white flower. Two of the offspring flowers are going to be what's called heterozygous, and they're going to have one gene for purple and one for white, but they're going to express the purple. And 1 out of 4 of the flowers that come from these two purple flowers is going to be white, right? So this is just another picture of the idea of 3 purple and white and 1 white flower coming from the crossing of 2 purple flowers. It's not important if you really understand that. This is more important. This is basically the genetics of autosomal recessive segregation. And the next 2 slides, this slide and the next slide, are really the only 2 slides you really have to understand the whole point of screening for recessive diseases. So we have here 2 parents, right? If they were completely hatched, they would be affected. If they had no hatching inside them, they would be what we'll call normal or typical. And a carrier, we're going to say is this kind of blue, but inside them, they're carrying these hatch marks. Now, it's important to understand that these 2 parents show no signs whatsoever of any, what we're going to call abnormality, because we're going to say for now that the recessive trait is going to be a disease. So you have these 2 parents who both look phenotypically completely normal. They marry and have 4 children. And again, this is independent assortment. It is random, but this is statistically what you'll get. So of their 3 children, 3 of the children will be phenotypically normal. That is, they will look normal, they will act normal, they'll have no disease. But 1 out of 4 of them will be affected. Because based on this punnett square, where here we're saying the disease, for instance, is the small b, right? When the small b and the small b get together in this 1 out of 4, you wind up with an affected individual. 3 out of 4 of them are going to look normal, but half of all the kids are going to be carriers like their parents for the disease. However, being a carrier does not have any phenotypic implications. It doesn't have any implications in your life. You're completely healthy. So the bottom line is, if 2 carriers were to marry, on average, 1 in 4 affected children will result. The only change between this slide and this slide is now 1 of the parents is a carrier and 1 is not. That is, 1 is carrying 2 genes for the dominant normal characteristic. When they marry and have 4 children, 1 out of 4 is going to be like this parent who's going to have 2 normal genes, right? And I hate the word normal, but we'll use it for now, right? 2 of them are going to be carriers, but they're not affected. Half of them are going to be normal and half of them be carriers. They set this up in a pretty funny way. The bottom line is, when this carrier marries this person who's not a carrier, there are no affected children. There's only 1 parent is a carrier. So the bottom line is this: if they're both carriers, 1 in 4 will be affected. And if 1 is a carrier, 1 is not, nobody is affected. The gene is still there and the gene is still being passed on, but we don't care because it doesn't affect the individuals. So for recessive inherited diseases, the bad news is an autosomal recessive gene can never be eradicated ethically by selective mating, because heterozygotes, which means those who have a normal and the recessive gene for disease, do not manifest the disease. The only way you could really get rid of the disease would be to tell every person who's carrying a gene for a disease that they can never have children. That would be completely immoral, and there'd be no reason for it, because the good news is an autosomal recessive disease can be completely eradicated if no 2 carriers marry. So what comes out of this is, I can eradicate the disease, but I have to do that every generation. That is, it's not permanent, right? That need ongoing vigilance, which is what screening is for. So I can make it that there'll be no children who are sick. I can't make it that there will be no people who carry the recessive gene. But again, practically, I don't care, because a person who's carrying a gene for a recessively inherited disease, but has the normal dominant gene also, has no disease. So we're more interested in the good news. We could prevent the birth of sick children. Now, this is a little aside, but it's important to understand. Unlike screening for a dominant disease, screening for an autosomal recessive disease only has repercussions for offspring. And it's really important to understand, because a person thinks they're healthy. They walk into the genetic counselor, with the lab that they're going to have their screening done. They're screened and they come back, they get the results back, and they're told they are a carrier from one or more different, let's say, recessively inherited diseases. They are still completely healthy. It has no, practically speaking, has no repercussions whatsoever on their life. All that matters is they need to be careful about who they marry, so that if the other person they marry has the same recessive gene, then they have a 1 in 4 chance of a child who's going to be sick. But you walk in healthy and you walk out healthy when you are screened. You just get more information. And we're going to talk about knowledge as power later. All right. So a short word about dominantly inherited diseases. I showed you the pedigrees for recessive disease. This is a pedigree for dominant disease, one parent affected. Right. So note that unlike recessively inherited diseases, right, the parent is also affected. This parent has the disease or the trait. Now you could look at it and say, maybe this person's disease is brown eyes, and this person's disease is blue eyes. In which case, right, the half of the children are going to inherit one of the genes for brown eyes, right, and actually one for blue eyes, but that's a recessive trait, right? And half of the kids are not going to inherit the affected gene from this parent and going to have blue eyes. Okay, that's really nice. We're talking about brown eyes and blue eyes. And again, I want to point out that when we say one parent is affected, we mean they only have one gene for the abnormality. If you have 2 genes for a dominantly inherited disease, often it's lethal in childhood anyway, or in utero. So the bottom line is that unlike recessively inherited diseases, right, we're talking about someone who is affected by the disease themselves and can pass on to their children. There's really no way to normally, in the normal course of things, to prevent that, although there are ways that we're going to discuss maybe, right? So what winds up happening if they're both affected, right? 1 out of 4 will be normal, right? 2 out of 4 will be affected, and again, 1 out of 4 are going to get the dominant gene from each of the 2 affected parents who each have one of the genes. They're going to be severely affected. I can just invite you. I wrote an article about designer babies that discusses a really interesting situation in which there are dominant diseases in which the parents would like to pass it on to their children, and want to do PGD, which we'll talk about later, to make sure they don't get the double dominant, which means a lethal gene. Okay, so this is basically the tree, right? The pedigree for a family that starts out with one parent autosomal dominant affected, one non-affected. And the reason this matters, for instance, is BRCA1 and BRCA2, the quote cancer genes that are more common in the Ashkenazi Jewish population are inherited in this way. And so it's really not the same discussion as we're going to have today about screening. Screening for BRCA1 and 2 is a really different discussion, because in that case, we're going to find out whether or not the person themselves is affected and have really no way in the normal course of doing things to prevent half of their children from having. All right. So screening for dominantly inherited diseases has repercussions for the person being screened, right? Which we'll discuss later. Fine. Side note, there are other kinds of inheritance. We were just discussing the simple Mendelian inheritance with one gene, with dominant recessive. There are things called X-linked genes like hemophilia. And again, you can look at my website. There's an article about hemophilia in halacha, right? And we can skip this. This is an example of cystic fibrosis now, which is a recessively inherited disease. And a little chart, which is very interesting to understand about screening, which is screening is not 100% foolproof. This slide is a little bit old, but the concept is important, right? We said before, 2 carriers we're marrying. This is the pedigree. 1 in 4 is affected. 3 out of 4 are not affected. Half of them are carriers. What's interesting is that the detection rate for different populations is different in this when you screen, because what you're doing is screening for a particular mutation, usually. So therefore, in the for instance, Ashkenazi Jewish population, there are some particular mutations that are most common to cause, let's say, Tay-Sachs, right? So in this case, for cystic fibrosis, for instance, people of Northern European Caucasian descent, the screening had a 90% sensitivity. There was a 1 in 29 probability of having the gene before you tested. And if you tested negative, you had a 1 in 250 chance, even after being tested, but that's still pretty low. However, if you were Ashkenazi Jewish, you tested for cystic fibrosis for this particular gene, it has a 97% sensitivity. Even though the pre-test probability was 1 in 29, which is the same, the post-test probability is now close to 1 in 1,000, which is 4 times less likely. So screening for the exact same gene in an Ashkenazi Jewish population is actually 4 times, gives you 4 times the confidence that you're not a carrier. All right, that's a little bit of a side note. That was all the good facts. Now we get to the good stuff, which is the good ethics. So if you didn't follow any of that, don't worry too much about it. This, I think, is much more interesting. What is the traditional Jewish approach to resolving any ethical issue? Right? So as I said, in Jewish law, traditionally, ethics and law are inseparable. That is, Jewish medical ethics is the application of Jewish law to medicine and science. You could compare the way Jewish law works actually to Western legal systems, right? That is, in the United States, we have a constitution, right, which is like the written law, which is like the Torah to Jewish people. We have oral law, which is the Talmud, which is comparable actually to British common law. And in reality, most law comes from common law, not from written law, and it's the same thing in Judaism. Much more law comes from the oral tradition, from the Talmud, than that is found specifically in the Torah. Then there's codes of Jewish law, which are statute books, and lots of case law, which are responsive. We're going to go through some of that. And here is a picture of kind of summing this up. And I think I may have included it in the handout, but I'm not sure. All right, so what is the methodology for investigating any ethical dilemma? You carefully gather accurate information. You survey Jewish legal sources from the Bible to the 20th century. You establish precedents from previous cases that might be applicable to the current case. So for us, we need to ask with respect to screening, why do you want to screen? When should we screen? Who should we screen? And by the way, who are we going to tell, right? So it's very important in medicine. We always ask the question, what are you going to do with the results? You should not do any test that you're not prepared to do something about the results, which will lead us to a little discussion about BRCA 1 and 2 if we have time later. Are there universal ethical issues raised that are not just Jewish issues, but just that the whole world has? And then are there theological problems with screening for recessive genetic diseases? So let's think about the why, when, and who, right? If you want to avoid any potential for an affected child, right, then you want to screen the potential parents in advance, because then you can find out in advance, is there any probability that there will be a child with a disease? And for instance, as we're going to find out, if neither is a carrier, or even if only one is a carrier, right, there is no potential for disease. We are putting aside the idea of spontaneous mutations that are extremely rare and really not part of our discussion. Let's say you want to just prevent the creation of an affected child. So then you do pre-implantation genetic diagnosis, which we'll talk about later, which basically means you're going to do your reproduction using fertility treatments and using in vitro fertilization. And you're going to check out each pre-embryo before implanting it and only implant healthy ones. And if you want to prevent an affected child from being born, then you have to test the fetus, which is amniocentesis, chorionic villus sampling, right? Now, I would point out that you really prefer not to get to this point, right? You'd really like to get to stop at this point because this has the least amount of pain for everyone involved, which we're going to get to. So if you do genetic screening of the potential parents, then you can avoid marriage or conceive children by IVF. So if you screen the potential spouses in advance, even before they meet, which is a system we discussed with you called Dur Shurim, right? Or going to something like the Call America J screen, and you call Jnetics in Great Britain, right? If you know in advance you're a carrier, you may choose not to marry somebody who's a carrier for the same disease. So I'd like to just point out, for anyone who thinks it's not very romantic, to immediately like scrub, that's I guess American term, scrub from your choice of potential mates, someone who's got the same carrier status as you. I'd like to point out the following. If we say in the Ashkenazi Jewish population that there's, let's say, a 1 in 30 carrier rate for Tay-Sachs or for cystic fibrosis, What that really means is the probability that two people will randomly meet and both be carriers is 1 in 900. And the chance of offspring is 1 in 3,600 who has the disease. But what also means is if you know you're a carrier for Tay-Sex, what percentage of the population are you really ruling out if you decide you will not date someone who's also a carrier? And the answer is 3%. You can date 97% of the Ashkenazi Jewish population without any risk. And most people, I think, would agree that having 97% field to choose from in order to avoid diseases which could cause death or severe disability is probably a worthwhile thing to do. If you do pre-implantation genetic diagnosis, right, then you'll only implant unaffected pre-embryos and you won't have any sick children. If you test the fetus and the fetus is affected, then you are somewhat stuck, and that abortion is probably the only way you're going to be able to avoid having a child with the genetic abnormality. So the ethics of genetic screening is closely tied to the ethics of choosing characteristics of offspring, right? Pre-implantation genetic diagnosis, IVF, abortion. There are a lot of issues that come in. It's important to understand that from a traditional halachic point of view, science and technology are morally neutral. It's the use of technology that has moral implications, right? We don't have a concept that says, basically, that we're playing God. That is anything that God has given us that can be used in a moral way is fair game. And so the example here is, if you would like to split an atom to make nuclear power, that's perfectly fine. You can heat and give light to homes. If you want to plant a dirty bomb in a train station in London, we're not quite as keen on that. That would be an immoral use, obviously, of nuclear energy, while making nuclear power may be a somewhat ecologically sound way to do it, putting aside any issues of what are you going to do with the waste. Okay. So what are some of the universal ethical issues and potential problems, right? Well, one is revealing information, which we'll talk about, right? Are you causing harm to the person who you're screening when you give them the information that they're a carrier? Informed consent, which is an issue that was raised before about tyranny of knowledge, which we'll talk about. Confidentiality, who should have access to the results? And that, at least in the United States, is a big deal because, at least until GINA, which is a law that was passed to protect people, employers could use the results of genetic screening for premiums for health insurance. So there would be a reason to not necessarily want people to know that you're a carrier, right? There's a slippery slope argument, right? Will screening lead to unethical behavior? Potentially abortion, right? Problems of mass screening. Are there advantages, disadvantages? Does Jewish law say you have to screen? So let's start going through some of these. Are we playing God from a theological sense? Are we interfering with nature? What is this prohibition of bad news? Is there an issue of confidentiality, which in Jewish law is called lashon hara, which we'll talk about briefly? And are we putting a stumbling block before the blind, which means, are we putting people in a position that they may do something which we feel to be unethical if we give them this information? So let's start like this. Is screening permitted or even obligatory? And if so, when should we test? Who should we test? And what are the ramifications of testing carrier positive before marriage versus after marriage? So we start here, right? Is screening included in the obligation to seek and accept medical advice? There is a biblical obligation to guard your health. And that's easily understood in terms of normal illness and risky behavior. It's very easy to understand that you should avoid dangerous situations. I don't get political, potentially wear a mask, be vaccinated and be boosted against COVID, whatever it is that you need to do to protect yourself, right? There is an obligation to heal, right? Surely you should heal. It's actually this week's Torah portion, right? So there is an obligation to heal, right? There's also an obligation to guard your health. Take heed to yourself and guard your lives carefully, which is mentioned twice, 6 lines apart in the book of Deuteronomy, right? And from here we learn in the Talmud that there's an obligation to guard your health. So we're in favor of doctors healing and we're in favor of people guarding their health. But, right, it's not clear that guarding your life includes guarding your progeny, right? If you are a carrier for a recessively inherited disease and you're only a carrier, you're healthy. So maybe there is no Torah prohibition, right, of not being screened. Maybe I don't have any obligation to be screened because to protect my offspring, which don't exist yet, right? In fact, let's say I'm not even married yet, right? Do I have any obligation? Where does that fit in? So nor is it clear whether marrying another carrier is a danger from which one is required to protect oneself. Let's say I know I'm a carrier, and I know the other person is a carrier. Do I still have any obligation from a Jewish halachic point of view to avoid marrying a carrier? So these questions are not so far-fetched, considering that the Talmud and the Code of Jewish Law understood genetics to some extent, right? So if you're a biblical scholar, you know, Hezekiah was censured for trying to prevent the birth of undesirable offspring. So I'll show you an interesting back and forth in the Talmud, right? This is a quote from, which is basically based on something that happens in the book of Kings and in the book of Isaiah. Hezekiah is the king of Israel, Isaiah is a prophet, right? And Isaiah comes and says to Hezekiah, you're going to die because you did something wrong. So Isaiah says to him, so Hezekiah says, what did I do wrong? What's the reason? Isaiah says to him, it's because you did not engage in the midst of procreation. He never married. So Hezekiah says to him, that was because I saw with divine inspiration that immoral children would come forth from me. Hezekiah says, I know my children are going to be really, really evil. And if you know, if you're a living biblical scholar, you know that it wound up being the son of Hezekiah was Menashe, was one of the most evil kings of Israel. So this sounds legitimate. Hezekiah says, I don't want to have children who are going to be immoral. Isaiah says to him, what concern are the hidden things of God to you? What you are commanded to do by God, you're required to do, and what is good before God, he will do. Meaning, not your job. Your job is to do what you're supposed to do. You're supposed to get married. You're supposed to have kids, right? You didn't do that. That's what you did wrong. What would you think would be the outcome of this in Jewish law? It would seem to say, don't look too much into the future. But you'd be surprised, right? So what's the practical outcome of Jewish law? So Moshe Feinstein, right, who is probably the preeminent decisor of Jewish law, at least in the United States, in the second half of the 20th century, was asked his opinion about screening for Tay-Sachs when the first screening was developed. And he was asked, should we be screening? So he says, this is my translation of his tshuva, which is in Hebrew. I have been asked my opinion regarding several questions. Is it proper for a boy or a girl to endeavor to find out their carrier status? If it's desirable, should the test be done during youth or only once one reaches the age of marriage? Should the testing be done publicly or privately? And this is what he said. And since that, if God forbid this were to happen, to have a Tay-Sachs baby, it would cause tremendous suffering for the parents of the child. It is appropriate for one who is already to get married to test himself. And thus it is proper to publicize the test in newspapers and through other avenues that would inform the public that there is a test like this. And I only bring this lest there be anybody who thinks, again, that we are playing God, that you just do what you're supposed to do, and it's on God's hands whether you have healthy or ill children. And that is not the traditional Jewish approach. The traditional Jewish approach is we do that which is within the bounds of ethical activity to avoid illness, right? Screening is not akin to playing God or interfering with nature. Screening is permitted and even encouraged in Jewish law. So we've established for now that there, with little to no dissenting opinions, screening is permitted in Jewish law, especially for these recessively inherited diseases. Interesting question of when should we test? And he wrote, since it's known that it's the nature of most people to suffer exaggerated grief over their personal problems, causing a person to imagine small things to be serious things and small concerns to be great concerns, particularly in our country of America, as is well known. Thus, heaven forbid that we should test young children that are still not even thinking about marriage. The majority of boys younger than 20 do not consider marriage and are not involved in this pursuit. So what was bothering Rabbi Feinstein was that children will not understand what it means to be a carrier, right? That they're going to be very upset because they're going to be told there's something wrong with you. And they won't be able to explain to them that this is only a carrier state and it doesn't really affect you. The bottom line is, he says, there's no reason to upset children by telling them that there's something wrong with them. So he says, but test before you are ready to get married. Okay, so that does not present any kind of medical issue for us. And he says also for this reason, testing must be done discreetly so that others do not know about it. There was a big issue about stigma. Sickle cell disease, which is mostly in the Black community in the United States, had a lot of stigma attached. There was a time when people who had sickle cell, right, who were carriers actually, could not fly, could not be pilots. right? There was a large stigma around sickle cell, and there's a large stigma in the Jewish community, at least in the past, around genetic diseases. And for women who typically marry younger, right, he says, you don't test before 18. And if it happens an individual boy or girl wants to marry earlier, they represent a very small minority, and they'll know about it anyway, they can be tested. So that is the opinion of Moshe Feinstein, which is followed by a good segment of the more Haredi Jewish population. Rabbi J. David Bleich, who's a Rosh Yeshiva at Yeshiva University, takes the opposite view, but still thinks you should test. He says it is certainly simpler, less traumatic, less time-consuming, less costly to draw blood for a Tay-Sachs test in conjunction with a routine blood test performed by a pediatrician during childhood. Moreover, if neither parent of a Tay-Sachs carrier, there's no way that any of their children could possibly be a carrier. It is certainly cheaper and more efficient to screen 2 adults, even if they're beyond childbearing age, than to test each child in a union blessed with multiple offspring. There happened to be a little bit of a problem with what he's saying, but the underlying message is exactly what, to some extent, J-Screen, Jnetics, and most of the medical community ascribes to. This is a small part of a long essay, which I put into the handout, which you're going to get, where Ed Bleich is arguing and saying that ignorance is curable by education. That if everybody was screened and we just knew who was a carrier, who wasn't, and then people just understood that's just the way it is, there would be no stigma. So therefore, he was in favor of universal testing during childhood, right? There's a little interesting twist to this about testing just parents, because as much as I hate to say this, that relies upon 100% marital fidelity. You have to rely on the idea that for sure, right, all of the children are really the offspring of the parents. And that actually is an issue that is considered in the secular medical community with respect to testing. But it is true, right, that if the two parents neither are not carriers, or neither one's a carrier, the child cannot be a carrier short of a mutation. So let's keep going. So when to test? Rabbi Moshe Feinstein, no mass screenings of children, screening individuals when they reach marital age. Rabbi J. Bleich, mass screening even children, young adults, right? How about informing someone of their carrier status? This is exactly what was quoted before. This is Rabbi Moshe Tendler, right? He says, knowledge is power. We generally approach knowledge as a liberating force. Knowledge makes us the master of our fates. But there is a thing called tyranny of knowledge. Sometimes knowledge becomes the master, it makes us the servants. When information causes anxiety but offers no way to reduce that anxiety, it controls us. And some argue that genetic testing for BRCA genes is just such a case. Now, this quote was from a while ago, and Rabbi Bleich and Rabbi Tendler, and I'm going to put in a shameless plug. I am publishing a book in which I updated my stuff about genetic testing. Even Rabbi Tendler, who died recently, was convinced by the end that it is worthwhile and probably almost an obligation to test for BRCA genes, because a lot can be done to mitigate. This is actually Randall Guthrie, and it's an interesting issue, right? Because his father, Woody Guthrie, died of Huntington's disease, which is a dominantly inherited, incurable, basically untreatable neurological disease. And so when the ability to screen, to test for Huntington's disease came out, they asked Randall Guthrie, do you want to be screened? And he said, no. He said, why would I feel healthy? Why would I want to know that I'm going to die of a horrible, debilitating neurological disease with the understanding that nothing can be done? Clearly, if something can be done and you can be treated, then there's a reason. But this is to some extent what Rabbi Tendler meant by tyranny of knowledge. Knowledge that is upsetting, that you can't do anything about. But that is not the issue with recessive diseases. This is an issue only with Down diseases. So is the knowledge gained from screening for recessively inherited diseases power or tyranny? With respect to recessively inherited diseases, knowledge is surely power. The earlier one receives the information, the more power one has. Who should we tell? Well, there's a biblical prohibition of hurtful words called the nos devarim, right? Will informing a carrier, particularly an adolescent, cause feelings of inadequacy, an illusion of being genetically defective, or fear, right? Well, revealing the information should only cause feelings of inadequacy in children who do not understand what carrier status means. So Rabbi Feinstein takes care of the problem by saying, so wait till they're older before they get married. Rabbi Bleich says, we're going to take away the stigma so people don't feel that way. So either educate the population to understand that being a carrier is not an illness, or screen only mature adults. Those are the two approaches, but it should not be a problem. Who should we tell? Who should have access to the results? So Judaism requires strict confidentiality in all private matters. Gossip is strictly forbidden. It's called lashon hara, unless remaining silent will harm a third party. Should relatives be informed? Now, this is really interesting. It's a much, much bigger deal for dominantly inherited diseases. Because a woman, for instance, who tests positive for BRCA1 or 2, her sister has a 50% chance of also having the gene. And so not telling her sister means that she's deprived her sister of knowing that she potentially has a gene for something with a increased risk of breast cancer and ovarian cancer. But there's also the issue that sometimes people don't want to know. And by telling them, you can't take it back. So should relatives be informed? Well, with respect to recessive diseases, right? Again, we're not telling anybody that they're sick, so it's much less of an issue. So does a prospective spouse need to know your carrier status if he's not a carrier? This is an interesting discussion for marriage counseling, I guess. But the issue would be, if you know, right, that the person that you want to marry is not a carrier and you are, do you have an obligation to tell them, right? And that's an interesting question, because there is no chance that the child will have a disease. There's just a 50% chance that the child will be a carrier. Will testing positive as a carrier before marriage cause difficulty finding a mate? Should you not test because now you're going to have to tell prospective people when you date, and is that going to be a problem? Well, truth telling is a key ethical value. You probably should tell your prospective spouse, and it should not be an issue at all, right? If the prospective spouse is not a carrier, and you have to take into account ignorance, but basically, there is no way that anybody is going to be sick as long as only one of them is a carrier. What are the ramifications of both parents testing positive as carriers after marriage? And this is what you really want to avoid, right? The option is to avoid a sick child, and will screening lead to unethical behavior? So here's the problem. So both parents are carriers now. We go back to Hezekiah, right? There's an obligation in Judaism to marry and have children. So what are the alternatives if you don't want to have sick children? Well, you could have a sterile marriage, but we saw from my quote from Hezekiah that Judaism does not really allow voluntarily sterile marriage. Adoption is a wonderful thing, but it does not fulfill the mitzvah of being fruitful, multiplying. Artificial insemination, surrogacy, egg donation, these are all things which I hear going to talk about next week, right? You can always do amniocentesis and abortion, which is really an area we prefer not to wind up in. Or you could do pre-implantation genetic diagnosis, right? So sterile marriage, we said, is forbidden in Judaism. You have an obligation to be fruitful, multiply in the case of Hezekiah. Adoption, we said, meritorious, does not fulfill the mitzvah. Right? Artificial insemination by a non-carrier donor has a lot of issues. Issues of adultery, which most people hold is not an issue, but is something that is discussed. Issues of paternity, issues of inheritance, right? And you really don't fulfill the mitzvah of procreation, right? Surrogacy and egg donation, same thing. Question of issue of adultery, of which there really is, according to most opinions, is not. But there are issues of who's the mother when you have surrogacy and egg donation. Fundamental ethical issues of buying and selling eggs and the use of a woman as an incubator for hire is another discussion, right? You could always do amniocentesis and abortion, right? And these are just some pictures of CVS, which is chorionic villus sampling and amniocentesis, right? But abortion is almost always reserved for danger to the mother, and having a sick child is not a danger to the mother. The consensus in Jewish law is that one may not abort for fetal anomalies, but there is a dissenting opinion. The majority opinion is Rabbi Moshe Feinstein, we quoted before, who says that abortion is absolutely forbidden, even for tay-sex. We do not abort unless the mother's life is in danger. We do not judge the value of life, right? The sole dissenting opinion, basically, is Rabbi Eliezer Waldenberg, who thinks that abortion is a rabbinic prohibition, right? And allows abortion up to 7 months for things like tay-sex, right? Amniocentesis itself has a risk we prefer not to get involved with, which is 1 in 200 risk of miscarriage from amniocentesis, at least at some point. Someone else may have better numbers. And interestingly, if Rabbi Feinstein has a problem with amniocentesis because he's afraid that someone will wind up finding out the baby is sick and will abort in a situation where they're not allowed to. This is a viable halachic route for if two parents are tested and are positive after marriage, right? PGD is basically where you do in vitro fertilization, you test for the presence of disease, and you only implant the healthy pre-embryos so that you avoid implanting any sick children, right? Interesting enough, excess embryos can be discarded or used for research, which is a whole discussion about stem cell research in halacha, which you can read on my website, right? And this is an ethically viable option for married couples. The last thing I want to talk about and then stop, because I know we're kind of running late, is something called Dor Yeshurim, which is just an interesting thing to know about. It's another approach other than going to a lab and being tested. It's a confidential premarital screening program started in the 1980s that tests for multiple recessive inherited diseases, right? The results are concealed from the people tested. If you're tested by Deuteron, they do not tell you what the results are, right? All that happens is when you want to go out, potentially on a date with somebody, right? You call Deuteron and you give your number and you give the number of the person who you would like to date, and everyone's given a number after they're tested, and Deuteron either says yes or no. And all that no would mean is you're both carriers. If you're not both carriers, the answer is yes. It's irrelevant if one of you is a carrier, it's irrelevant which one of you is a carrier, it's irrelevant if neither is you a carrier. It's a way to avoid any offspring that are sick without any stigma whatsoever. You don't know that you're a carrier. They don't know that they're a carrier. You just know that it is safe to marry and you won't have children who are sick. Interestingly enough, it is a standard screening method in large parts of the Orthodox Jewish population. All of my children go through this. Is it a viable option? Well, these numbers were pretty impressive to me when I saw them. In 1969, there were 50 cases per year in the United States of Tay-Sachs. In 1970, screening was started. 1990s, 4 to 5 cases per year. And basically, Deuteron has virtually eliminated from the Orthodox population, in particular in Israel, any cases of Tay-Sachs. The Tay-Sachs unit in New York was shut down. And it's more common to see a Tay-Sachs baby in someone who's Irish in the United States than in someone who's Jewish. So it does work for those people who are willing to be within the system. It is a very successful, good fit for a segment of the Orthodox community called Shidduchim. It's practical for a small minority of the other Jews, right? Because the results are not revealed and they will not test if you're involved in a relationship or married already, right? So what do we come up with? There is no issue of playing God. There are no health ramifications for the person tested, right? It gives you information that avoids painful outcomes and avoids problematic acts, right? Genetic screening for recessive traits is a great boon to the Jewish community and the rest of the world. And whether done confidentially through Deuteron or publicly through, let's say, Jnet, or was it Jnetics, right? The information gained provides the opportunity to make wise and informed decisions about the future. There are no health ramifications for the person being tested. But by utilizing such means, we can look forward to a future filled with more hope and less disease. The issues are not as simple when deciding about testing for genes for hereditary breast cancer. That's for another time. And I presume the answer to this is no. I put in, they asked me other stuff about mitochondrial diseases and
we don't have time for that.
I know, no, so I'm skipping off.
What I will just say to the audience is that's what we'll discuss next week.
Okay.
I know.
So
thank you so much.
Website www.jewishmedicalethics.com and take a look.
Thank you so much. That was absolutely fascinating and a real whistle-stop tour, I think, through the basics here. I'm sure there are going to be many, many questions later. I'd like to say to everyone, we are going to extend the time to 9:30 today because there's just so much here that we'd like to unpick. But before we go on to questions, I would like to introduce Dr. Juliette Harris, who's a specialist genetic counsellor at the London North West Healthcare at NH Trust and the Mount Sinai School of Medicine. She's a genetic counsellor for the Ehlers-Danlos syndrome, EDS, the National Diagnostic Service based in the Northwest Thames Regional Genetics Centre and the Allied Cardiology Clinics at Barts and Great Ormond Street Hospital. The EDS service is a specialist one for people with a very rare form of genetic disease. And it basically, I'm sure that Juliette will explain exactly what genetic counselling involves. But her role also includes research, and in the past she's also really been looking very much providing counselling and advice for the NHS for Tay-Sachs carrier screening and for Jnetics programme. And she's also, of course, a trustee of Jnetics. So I will hand you over to her, who will be able to very much tell you what it's like to be working in the field of such diseases.
Thank you so much. You can hear me well? That's lovely. And if I can have these slides set up, it's lovely to be here in the meantime with Jewish Renaissance. And I just wanted to thank Dr. Eisenberg for such an incredible endorsement for autosomal recessive carrier screening as well, from an ethical point of view. Excuse me. So the aim of Jnetics, the charity I'm talking on behalf of today, is to make a real difference to the prevention, diagnosis, and management of Jewish genetic disorders by raising awareness, such as events like this, and facilitating access to the best available information, services, and support for those affected and at risk. Next slide, please. So Jnetics, the charity, was established around 12 years ago and is the only cross-communal charity devoted to the prevention of Jewish genetic disorders. We screen currently for 47 of the most severe recessive Jewish genetic disorders. And screening takes place across the community, in schools, in universities, which are heavily subsidized, the screening by Jnetics. And also we have an adult clinic. And tying in with what Dr. Eisenberg was talking about, our aim is to try and give couples as many options as possible if they're both found to be carriers of the same condition. And our aim is trying to get people to have screening and to encourage carrier testing before they start a family. It's one of our critical aims of Jnetics. We have screened a lot of people. Since 2014, 4,000 people in our community have been screened to date. At least 4 carrier couples have been identified that we know of. That's 4 couples who can avoid having a baby with one of these serious conditions. And I really want to point out that Jnetics has a unique model in terms of its collaboration within the NHS. That means Jnetics obviously organizes everything and rolls out the screening, but the actual clinical governance, the confidentiality, the consent, all these important ethical issues that need to apply to a screening program are embedded within NHS practice. And the results are stored confidentially there. Jnetics as a charity has no access to the results. So there's extremely secure governance around the screening program. And I think this is absolutely unique and essential to providing an ethical screening for our community. Next slide, please. So Jewish genetic disorders are more common in people of Jewish ancestry relative to the general population. And I'd like to point out, and I think Dr. Eisenberg mentioned this, that, like, for example, Tay-Sachs, if you're fully Ashkenazi, there's a 1 in 25 chance you're a carrier, but it is about 10 times reduced, but still about 1 in 250 people in the general population are carriers of Tay-Sachs too. So it is important to remember this. The other thing I'd like to point out is that we are not the only community to have increase of certain conditions within our community. Of course, it's very well known, sickle cell anemia, as Dr. Eisenberg also mentioned, is increased in the Black and African community. But I have to say, and I always say this, we don't have an extra burden of genetic disease, although it may seem that way sometimes. We're just an incredibly studied population. If you think of Mount Sinai School of Medicine, where I trained, the amount of Jews that willingly take part in genetic research to look at their genes. And it's really important to know that I think we're reaping the benefits in our community of allowing ourselves to be so well studied. So I always say to people, I don't want us to consider that we have an increased genetic burden across anyone else, but we're very fortunate to have the information about our genes and available for screening. So it's a really obvious point that Jewish genetic disorders are associated with our ancestry going way back and not observance. It's completely obvious, right? But I'd like to point out that people who are not connected with our community, people who maybe are unaware of their risk, will not know how to access screening. And so we have an ethical responsibility, I believe, to increase awareness, not just across our community of Jewish genetic disorders, but beyond it as well. Jewish genetic disorders are present in the Ashkenazi, Sephardi, and Mizrahi population. Next slide, please. I'm not sure you can see it so clearly, but what I want to show you is the top circle are conditions that are increased in the Ashkenazi community, and the bottom yellowish circle are those that are increased in the Sephardic Mizrahi disorders. And I am really, really interested that there is an overlap, including Tay-Sachs, between these communities. And for me, this really shows that historically, we know historically that we came out of perhaps Hebraic population dispersing from the Middle East, but our genes also show us that we have a unique profile, whether we're Jewish, Ashkenazi, Mizrahi, Sephardi. We have a unique profile with common genetic variants out of the Middle East. And that little overlapping bit of the Venn diagram really shows that that is true. And I really always enjoy evidence from genetics, which kind of also can prove our historical background as well. So these 47 conditions, how did Jnetics choose these conditions? Well, they are very stringently chosen. They are all autosomal recessive. As Dr. Eisenberg said, carriers of these conditions are not affected themselves by the condition. Very important that, especially when we're screening in schools and university, that they have the information beforehand, but they understand that they will not, their health will not be affected by finding out they're a carrier, and that this only affects it if their partner is the carrier of the same condition. All these conditions are severe, they're life-limiting, life-threatening, there's no cure, it's childhood onset, and very importantly, there is very little variability in the condition. So there are some genetic conditions or chromosomal conditions, like Down syndrome, for example, which can vary greatly between children. But with these conditions, unfortunately, there is no variability. They're incredibly severe. And these reasons is why they were chosen as suitable for a screening program. And as Dr. Eisenberg mentioned, and I think one of the rabbis was saying, it's about avoiding great suffering. There is no doubt that these conditions create huge amounts of suffering for both the child and the family. And so again, these are the reasons why these was found suitable to be in the screening program. These conditions, we actually expanded recently to include these conditions, were reviewed and approved across multidisciplinary teams. We had NHS Genetics, Northwest Thames Regional Genetics Service experts involved, scientific and medical advisory boards, trustees. We also chose conditions that were in line with what Israel does within the Ministry of Health. So I wanted to just explain to you that there's an incredible lot of thought went in to choosing these conditions. So taken together, there are 1 in 5 of our people who are of Jewish ancestry is potentially a carrier for one of these conditions. You may be surprised that it's really quite a high frequency. And pretty much I've worked out there's probably 8 people on this Zoom who are carriers of an autosomal recessive condition such as these that we cover. And I'm probably guessing that most of us are not aware of this. And that's exactly what Jnetics is trying to do. By normalizing, and Dr. Eisenberg spoke a lot about this, by normalizing this process, by destigmatizing it, by making it a normal process. We've been going into schools for 6-7 years. The kids are expecting it. I'm often surprised where they're like, yeah, they kind of share that they're carriers. And sometimes I'm a bit like, oh, that's your private information. But they're now beginning to see that it's nothing to be ashamed of and that it's normal to be a carrier of one of these conditions. So fortunately, the rollout and making it population-wide and available and accessible in terms of people being able to afford screening, and Jnetics heavily subsidizing it, means that this screening program is being widely accepted and adopted by our community. Next slide, please. Oh, sorry, we're just going to stay on that slide for 1 second. Sorry. So again, I do thank Dr. Eisenberg. He gave a fantastic introduction to everything that I want to say. So I only need to briefly explain about BRCA testing. You'll notice that Jnetics does not offer BRCA testing or screening, as in looking for genetic alterations in the BRCA1 or BRCA2 gene that significantly increase a person's risk of breast or ovarian cancer. And as Dr. Eisenberg mentioned, if you find out you're a carrier, you've got options to reduce your risk, such as surveillance and surgery. But currently, BRCA testing is not currently suitable for a population screening program. It takes place currently in a clinical setting only, based on referral due to a significant family history or medical personal history. But we are beginning, Jnetics and other people are beginning to really see that we may have a moral obligation, really, given 1 in 40 people of Ashkenazi background are carriers of BRCA. We may begin to need to explore ways of creating a population screening that is very clinical in nature, that protects its participants, that really gives them the information in advance so they understand the implications of being a carrier, but it may be incumbent on us now to find a way of offering this to the community. So Jnetics, although there is not currently a screening program for BRCA, we do raise awareness. Many people do not realize that anyone who's Ashkenazi Jewish and has had breast cancer is eligible for genetic testing and just needs to go to their GP for referral for genetics. Also, anybody with ovarian cancer can access genetic testing and other aspects as well, and specific patterns of family history. So I do always say when I give this talk, if perhaps one person hears me say that and it triggers them to go and speak to a GP, perhaps they'll end up being able to access important genetic testing for themselves. Next slide, please. So how does genetic screening work? What does it actually look like in practice? So anyone who has one Jewish grandparent is eligible for genetic screening. And how do they go about doing it? Well, all they have to do is self-refer. It's an online registration process through that website at the bottom. And it works on the principle, the ethical principle of autonomy. This is a personal choice to have screening. We don't send people, we don't go around like telling people they have to join up. This is a completely personal decision so that people can take control of their health and the future health of their children. And it's a similar process, whether in school, whether in adults clinic, whether in university. It's a similar half-hour process that involves the self-referral, as I said. Jnetics sends out a screening pack that includes a saliva kit. There's then a pre-arranged time to speak with a NHS designated genetic counsellor. And then there is, and I'll talk a little bit about what happens during that appointment. And then the person decides to consent and sends the pack back to Jnetics. It's sent off to a laboratory and they get the results about 8 to 10 weeks later, faster if someone's pregnant. Next slide, please. So in the Zoom session with the genetic counsellor, what is discussed? What have I discussed hundreds of times over with these patients? And as I said, the same things discussed, whether there's a teenager in school or a university student or a couple coming in for preconception testing or even being pregnant. So what do we discuss? Next, please. I talk about the 1 in 5 chance to be a carrier. Next, we review the family tree. Next, to see if there's somebody affected in the family or something we need to know about above and beyond what the questionnaire that they filled out has been. We explain autosomal recessive inheritance. You can't fully consent someone unless they understand what we're doing and why we're doing it. So it's really necessary to go through all this information to get proper consent. Next, please. So we tell people, we briefly only mention it to university or school students because it's not relevant to them at that time, but we want people to know that there are options and that even someone who is not thinking of starting a family, when it becomes relevant, there are options available to them. Otherwise, we wouldn't be doing the screening. And Dr. Eisenberg as well said, he talked, I don't need to repeat it, but for a couple who are not yet pregnant, they have the option to have IVF, to selectively implant only embryos unaffected by the condition for which they're at risk. Next, please, we also discuss, again, thank you, Dr. Eisenberg, for so eloquently discussing this, but we discuss the option if someone is pregnant already, that they can choose to test the fetus to see if the fetus is affected or not. And again, as discussed already, that comes with a risk of miscarriage because it's invasive. And so really, to be honest, you wouldn't want, the option to have prenatal testing should only be done by a couple who is considering terminating an affected fetus because they could end up with a miscarriage just by having this. And then at the end of giving them all this information, the person can choose to sign the consent form or not. If they agree to go ahead to have testing, next please, then they do the saliva kit and so on and so forth. Obviously, just to finalize this, is that if after all this we identify a carrier couple who are both carriers of the same condition, we would then spend a lot more time with them to explain their options, whether that's prenatal testing or through IVF. And so that's a whole extra appointment and session to spend with them sensitively talking about their options. Our job is not to tell people what to do as genetic counsellors, but to provide options that work for them, that something that they can live with, something that's important to them, and something that feels right to them as well. So as options as a genetic, my role as a genetic counsellor is to make sure people appreciate all their options. So thank you. That's my little bit for now. And at the end of the presentation, my colleague Gila will tell you a bit more about our cross-communal work and our fundraising work as well. Thank you very much.
Thank you. That was absolutely fascinating. I've heard over the years so much about Jnetics, but never really heard the details so wonderfully expressed. So I'm very, very grateful to you, as I'm sure we all are. We're going to go over now to questions, but before we begin, I just want to remind you, this session is being recorded and will be available publicly, so it's not a good idea to share personal details. I know a number of you may well have questions that, really do relate to genetic counselling, specifically for Juliette. And so I can ask you, in that case, it would be better if you were to contact Jnetics directly and leave those personal questions for another time. But to look at more general questions now, I know there have been a number of questions in the that have come through the chat. I'd like to start with Angela, if you'd like to ask your question.
Yes. Thank you, Rabbi Civil, and thank you to both of you for wonderful presentations. I actually have 3 questions, a one and a both. So my question for Dr. Eisenberg is really about the differences in the ethnic reliability. So you said that when you shared one of your screens showed that there was a reliability for Jews and reliability for Blacks and so on. And so my question to you specifically would be why there is that? What is it technically that makes it more or less reliable? I think also, Dr. Harris, you said something about Jews being studied. One of the things that's very advantageous is that Jews have been so well studied from a genetic point of view. And I wonder if you have any observations as to why Jews have been so well studied. And then to both of you, it's I think that there is a kind of a very blurry area with eugenics here. And I'm sure you've met this question before, and so I wonder if you have any observations as to whether this is manipulating a population. So 3 questions, a one and a 2.
Should I go first? Okay. Well, the answer, interestingly enough, I probably was not the person you should be asking about the reason for the differences in sensitivity, but I'll tell you. Imagine that the gene has 100 base pairs, and it's just, there's 100 letters in a row, and it's the alphabet. It's actually, let's get simple, 26. There are 26 letters, and this gene is A, B, C, D, E, F, G through Z. That's normal, okay? In certain populations, the mutation, let's say, will be at D, E, F.
Mm-hmm.
That's what the mutation is.
Yes.
Let's say in Ashkenazi Jews, whenever there's going to be a mutation for Tay-Sachs, 97% of the time, I'm making up that number, but let's say 97% of the time, it's going to be a defect in DEF.
Yes.
Okay. When they do the screening, they're looking for specific genes. That's how the order of the genes. They're not printing out the alphabet. They are taking, the mechanism requires my taking something that says, I'm looking for DEF. Instead of, it should say ABC, and it says DEF. So I'm looking for a marker for DEF.
Yeah.
But an error at MNOP will also give me a mutation in the same gene, but somewhere else. So if I'm only looking at DEF, right, I'm only looking at one part of the gene, right, the probability that I will pick that up, right, in a population in which the mutation is somewhere else, is very low, right? So there could be, the punchline is there can be more than one different mutation that can cause a disease. But in a given population, since we're talking about genetics, people be related to some extent, right? we tend to test for the most common mutations. So if that mutation is less common in a different population and something else is causing it, your screening is going to be less effective unless you test for that other gene, that other mutation also. And I really would like genetic counselor to correct me if I'm explaining this wrong, but that's basically the idea. That is, I'm not just looking at the whole thing and saying, do I see something wrong? I am in advance looking specifically for mutations, and the probability of that mutation causing disease in a given population is how reliable the test is going to be.
So someone has decided not to test for disorders that may affect other ethnic groups. Is that what you're saying?
No.
I'm not saying.
What I'm saying is that, like I said, today in America, right, it is more likely if you see Tay-Sachs that it's someone who's Irish than someone who's Jewish. Now, I know they're Irish Jews, put it aside. Irish Catholics, actually. And in fact, our Victor Center for Jewish Genetic Diseases had an outreach to the Catholic churches because that's where the gene, right? But it's not a given that the mutation causing Tay-Sachs in the Irish population is the same mutation causing Tay-Sachs in the Jewish population. So therefore, you only pick up those mutations that you know about. You don't pick up a mutation that you don't know about. But that doesn't mean the disease isn't there. So when we say that it's not, yeah.
No one else is doing it for other populations.
Oh, I don't.
They are.
Yeah, I mean, I presume they are.
Okay, thank you. All right, thank you very much. I don't know if Dr. Harris would like to say why are Jews so well studied?
So I was jotting down some notes when you asked that question, and a few ideas came to me.
Okay.
We do tend to live near big health centers, to be honest. We don't tend to live by virtue of needing to be near a synagogue. You think of where Jews have settled. They are often very near big health centers. And that is actually one fact that I knew about already. Think of the population in New York, how many hospitals we have access to.
Yeah.
There are many Jews involved in research progress. I worked under Dr. Robert Desnick, who was head at Jnetics in Mount Sinai. So there were also Jews, very academic, very medical, driving a lot of this research. I think, as Moshe Tendler has discussed, Dr. Eisenberg mentioned, knowledge is power. And I think ultimately Jews are people of the book. We're very academically curious. And I think, I just think that there is also a spirit of community, a communal spirit amongst many Jews. And I think that all these factors probably go into, why would Jews get on board and involved and not suspicious of research the way perhaps other groups may be. And it might also be that we know people can trust people because it's from within the community. So these are some of the ideas. I don't know whether anyone thinks that resonates with them. I suspect it's a whole range of factors. So that's just some of my ideas. But I just wanted to respond to what you said, and I don't think Dr. Eisenberg's yet commented on this. And I'm not an ethicist, but just when you briefly said the blurry area of eugenic observation, and I made some notes before I came, specifically around Galton, because I studied in what was used to call the Galton Center in UCL, University College London, which has now been renamed. And he practiced the idea of improving society through selective breeding at a population level. So how do you get populations to be more and more pure or more and more impressive? But I think that it's when we're just talking about the elimination of serious or allowing people the option of not having a child who's desperately ill, I think it's two different things altogether, avoiding suffering versus trying to elevate the human race. And there's nothing in the screening that would go along with that. I don't know whether that's a good enough reason, and maybe somebody else wants to contribute.
Did Dr. Eisenberg want to say that?
Well, I'm sorry.
Sorry.
Eugenics is a very big issue. And in fact, again, it's a different talk, but there were eugenics societies around the world before World War II. The United States had fairs, like eugenics fairs, like we have, I don't know if you have those in England, but state fairs, we would bring, you get an award for the best cow, they would give awards for the best genes, right? To some extent, eugenics was a major issue until the Nazis gave it a bad name. It's the only way to put it. It became so abhorrent afterwards that it's kind of dropped, but there's no question. And that was some of those slides, if we had time, which are pictures of front covers of magazines. And there's no question, as we develop CRISPR and things like that, where CRISPR allows you to change genes, there is no real reason, right? I don't mean ethical reason, I mean scientific reason why you will not be able to choose any traits you want to change, right? The way it works now is we're only after disease, right? But there is no particular reason why we will not be after good baseball players, right? Taller people, right? And all, whatever, smarter, faster. And that is going to be a very, very big challenge of how you're going to control technology. Every technology is like that, right?
I'm going to have to sort of just interrupt that, because this brings us into a huge new area and we're beginning to run short of time. And we have 2 more people who would like to ask questions. So thank you, Angela. But if I could ask Patty, Patty Collins, if you'd like to come and ask your question.
Just unmuted. Yes, it's been really interesting. I was interested in the BRCA testing. I mean, what difference has it made for women and having the BRCA test? And what percentage of Ashkenazi women have it? And do you see any ethical questions relating to that?
Who are you directing the question at?
Did you want me?
Who are you asking the question to?
Why don't you start, Juliette?
Yes, Juliette, start. And if Daniel, you have something to offer, I'd be
That's
interested.
why I really apologize that I wasn't trying to hide myself, that my video wasn't on before, but I have rectified the situation. So sorry, here I am. I can give some basic information about BRCA very briefly. I am not an expert in the field, it's not my field. But in terms of BRCA testing, when you're saying what difference has it made, do you mean to an individual woman who is discovered to have a BRCA change?
Well, that could be that, but also in general. I mean, what difference has it made for Jewish women in general? And yeah.
Okay, so it's at the moment, of course, it's only on an individual level that someone has BRCA testing. So I can only really speak for that. Somebody else might be able to speak elsewhere. But if someone's found to be a BRCA carrier, they are eligible for annual MRIs and mammograms. They can have risk-reducing mastectomy and reconstruction that really reduces their risk of getting breast cancer. Some people are eligible for removing their ovaries. Unfortunately, ovarian screening does not work. It does not effectively pick up ovarian cancer. There's medications, there's chemoprevention medications as well. So there's an awful lot of options for a woman who's found to be a BRCA carrier in terms of breast and cancer, breast and ovarian screening and surgery options. So it's made a huge difference to those women. I believe, and I might be wrong on this, somebody else might be able to correct me, but I believe only about 10% or even less of women who are BRCA carriers know that they have that risk. There are 90% of women who are walking around completely unaware of what a high chance of breast cancer, up to 70% lifetime risk of breast cancer, and BRCA1 about 44% chance for ovarian, and BRCA2 about 17%. And there's male ramifications as well for BRCA2 in terms of prostate, pancreatic, and male breast cancer. So one of the reasons why we're hoping this will be able to help with population screening to get more women aware of their risk in the future. I hope that answers some of your question.
Yes, thank you. That's very important. And do you think there are any ethical issues relating to BRCA testing?
Actually, Dr. Eisenberg already answered this a little bit, I think, in the respect that because there is so much that you can do to prevent and reduce the risk of cancer, I believe we may even have a responsibility
to do it,
to support screening in the community. I'll hand to Dr. Eisenberg to carry on with that.
There are additional interesting ethical issues. This is a real case from Israel, from one of the hospitals. I was in Jerusalem teaching one year, told the story of a woman who had breast cancer, was tested, found positive for BRCA, and it refused to allow them to tell any of her relatives for various reasons, social reasons, which I don't want to go into. But to some, it's worth going to this much. because the issue is, will this cause stigmatization on other people in the family, right? The question would be, if you knew, right, that some information that you found out about yourself had a very strong probability of affecting first-degree relatives, and the thing that you found out has implications with respect to possible life and death decisions, there are obviously major ethical issues that come up. Do you have an obligation to tell? The flip side is, you're Randall Guthrie, and you say, I don't want to know, right? One of the issues, the practical issues is, how do you decide, right, to give somebody information which will change their life irrevocably, when you don't know if they want to know or not? Because part of autonomy is the right not to know, right? So we assume that, of course, right, I have an obligation to tell you. But what happens if you say, I'm a very, very nervous person, right? I don't want to know. It's going to be tyranny of knowledge for me. I'm going to spend every moment for the rest of my life worrying, am I ticking, genetic time bomb? I don't want to know. Well, you can't ask me, by the way, do you want to know if you are a carrier for BRCA, because that's kind of a giveaway. That's a very, very hard thing to overcome. That's just one example. Luckily, screening for recessive diseases is a much, much more benign area. It's got multiple positives, and there's virtually no downside. The real downside, I'll tell you a downside, right? It's not of screening, but of the reality is, I once got a phone call from a couple in Miami, Orthodox couple in Miami, who were engaged and then got tested and both found out they were carriers, I think, for Tay-Sachs. And that is it's not hopeless, because you can always do IVF and PGD, but basically, right, the only downside is theoretically not being able, or choosing not to marry your, what's called in Yiddish, beshert, right? The person that God has decided is for you. On the other hand, right, if you want to not marry, then marry somebody else, that's probably your beshert, the one you married. So, but there's really no downside. It's information that won't make you sick. You can share with every relative, and it won't make them sick, right? All it does is gives you information that allows you to not let any of your children be sick. So I just want to put that plug again. But no, for dominant diseases, there are real issues, and it's another whole discussion.
There is a very different thing for the dominant diseases and the recessive ones. We have one final question. Ian, if you would like to join us. Ian's the chair of Jewish Renaissance. If you'd like to join us now.
And what a fascinating set of information we've had. I'd just like to ask about screening out diseases, testing and screening out diseases and disability, and obviously particularly inherited diseases or disabilities, deafness, Down syndrome, and so on. But while I've got the floor, I'd also like to ask about differences in testing regimes between the three large Jewish populations of Israel, America, and the UK. What and why are there testing differences in the regimes? Thank you.
Juliette, would you like to take that, particularly with the differences between America and what Jnetics does in the UK?
So as far as I'm aware, so we're quite aligned with what the Israel Ministry of Health does. They have like basic testing that they offer everyone free. And then there's like extra level testing people can pay privately. So we're quite aligned with the free service that Israel's identified to offer to people in the Israeli population. I believe that in America, there's a lot more available. They've expanded greatly. And actually, Dr. Eisenberg might be able to give us more information, but there's a lot more available, most of which is done commercially, and therefore there's a lot more available when you have commercial testing, and perhaps conditions that are variable, conditions that aren't along our lines of only severe, life-limiting, life-threatening, etc., giving people more choice as to what they want in terms of screening. So I think they're probably the main differences. I think there's a lot more available in America. Over to Dr. Eisenberg, who can maybe tell me more about that.
I'm going to read into your question as the following. How do you decide what to test for? Because to some extent, that would lead to the differences. And that's a very important question. In America, theoretically, the way it's decided is what is the incidence of what's the carrier rate of the gene, and then how severe it is. So for instance, I believe that the number they were using, I could be wrong, is at 1 in 100. Anything that's less common than 1 in 100, right, is considered to be not very common and therefore not worth testing for. Because understand the tests are not perfect. There are false positives, false negatives. So J-screen, I think in America is testing for 200 diseases. I'm not sure how many you're testing for there. But understand, again, if you're not tested, right, if the odds were if there's a 1 in 1,000 carrier rate, the probability that 2 random people are going to meet each other and both be carriers is 1 in a million. So you ask the question, is it worth the money, right, to be able to pick up the 1 in a million times where 2 people will be carriers and then 1 in 4 of the children will be sick? So basically, you're trying to pick up a 1 in 4 million chance of a sick child being born. If it's 1 in 100, right, then the probability randomly people meeting is 1 in 10,000. All right, so you have to decide now, is 1 in 10,000 a significant risk to spend, the money on? You also have to again decide how serious disease is. It's very interesting. You're muted.
Ian, unmute yourself. We can't hear you.
No, that's all right. I wasn't responding.
Oh.
But thank you for the information. I thought actually that's sort of statistical analysis. What rate justifies the expenditure? And now there's a philosophical or an ethical question.
Right, but that's true all of medicine. I mean, in a simplest sense, I don't know how vaccination is paid for in Great Britain. But if I said to you, you could either vaccinate 10,000 children for measles or pay for 1 person in the ICU for a week, right? Yeah. That's not a question which I'm implying is an obvious answer. I'm saying that's the way that works, right? One of the most interesting topics that I lecture about is exactly that question. Who lives, who decides, who lives, who dies, who decides? That's not an easy question. And on the societal level, it's not an easy question. There's the micro allocation, there's macro allocation, right? What I want, what's in my best interest may not be what's in the best interest of all of society. Society has to decide for everybody, and that may not work out best for your particular family. So that's the way it works.
So I'm going to jump in here now because I'm very aware that our time is up. And say to everyone, if you had further questions, we're sorry we didn't get to them tonight, but do feel free to email either Dr. Eisenberg directly through his website, or you can email Jewish Renaissance or Jnetics, and we will pass those questions on to Juliette or to Dr. Eisenberg. There is a lot about this that I know will affect people personally. And obviously for confidentiality reasons, we can't go into personal stories in great depth here. But if you have a personal story related to this and you want some advice or further information, do contact Jnetics and us. And on that note, I'm going to leave my thank you with a personal story. I'm, for those who don't know me, the director of Jewish Renaissance. And you might ask, why is a Jewish arts and culture magazine doing a session on genetics, and particularly genetic screening? Well, aside from the fact that I think Jewish culture is very broad and medical ethics raises all sorts of interesting philosophical questions that should be part of a Jewish cultural debate, I have to tell you, I have a personal investment. When I was a young child in the 1980s, very, very close family friends had a baby just a few years younger than me. And this little girl developed as normal until she was about 11 months old. And probably had she gone on to be healthy, I would have been her regular babysitter. But at about 11 months old, she started to get ill. And she'd begun to speak, and suddenly she started losing her speech. She had mobility, she was crawling, and she started to go down. Normally babies improve and their use of their limbs gets stronger and stronger until they're walking. But this little girl, and I'm not naming names because I don't want to tell, you know, the family's story without their permission, but she didn't. And in fact, she began to lose her ability to crawl. It was the early 1980s, and people didn't really know as much about genetic diseases as they do now. And when a child who seems to be developing healthily suddenly goes downhill, the next step normally is that social services get called, because the assumption was that the child is being abused in some way. Her doctor didn't know, couldn't spot that there was a reason. And in fact, social services tried to take this little girl away. It went to court. My mum was a paediatrician and a geneticist, and I'm going to tell you all next week about her because she worked on the beginnings of IVF, and next week we're doing new reproductive technology. But my mum knew this couple very, very well and was positive they weren't abusing their child. And my mum said, this could be something else. And she was the one, there's complicated testing, but like one of the significance is a red dot. Anyway, she picked up and she realized that the child had Tay-Sachs. And one of my earliest memories is my mum being called as an expert witness in a terrible, terrible court case to go, this child is ill, not abused. And then watching this little girl over the next 4 or 5 years get sicker and sicker until she died. Tay-Sachs disease is a horrible, horrible disease. My mum switched disciplines because of this. She focused much more on genetics, and she founded something called the Tay-Sachs and Allied Diseases Association at the Royal Manchester Children's Hospital. And it was the Willink Laboratory at the Royal Manchester Children's Hospital that started widespread genetic testing in the UK. I'm incredibly proud of her. Sadly, she died several years ago, and at that point, that organisation was passed over. Jewish Care took on a lot of the responsibilities for genetic screening, and then down the line, Jnetics started as an offshoot of Jewish Care. And Jnetics is now doing work that I think my mum could only have dreamt of. It's a fantastic organisation, and I am personally invested, but what I'd like to do is pass over to the current CEO of Jnetics, because I want to support their work to prevent the same thing happening to families as happening to our family friends 30, 40 years ago. No one should have to undergo that kind of suffering and watch what happens to a child. So let me hand over to Nicole Gordon just for 2 minutes to give you some insight in how you can support Jnetics.
Thank you very much, Aviva. It's a very, very moving story, and thank you for setting the scene. So good evening, everybody. My name is Nicole Gordon. I'm the CEO. I'm well aware of the fact that this is way overrun, so I will keep it really, really short. But I think, as Aviva sort of pointed out, we exist quite simply to save lives. Our mission is to ensure that no young parent should have to endure the heartache of giving birth to a child with one of the devastating genetic illnesses that we test for. We're unique. We're unique because we're the only cross-communal charity in the UK testing young Jewish adults in schools, at university, and through our genetics clinic, which targets young couples. As a charity, we have achieved so much in the last 18 months, increasing the size of our panel from 9 to 47 conditions. So Tay-Sachs is just one of the 47 conditions. We now include disorders that are prevalent not only in the Ashkenazi community, but also in the Sephardi and Mizrahi communities. We have hugely increased our profile within the community, and we have moved to a virtual screening offering in the clinic and at universities as a consequence of COVID. On the other hand, as we have increased and continue to increase the relevance of genetics within the community, this has put added pressure on the charity financially, in addition to the devastation of our fundraising plans due to COVID. Although over the last year we have successfully introduced a number of small fundraising channels and events, they have in no way compensated for the loss of funds due to our inaugural dinner, which was actually cancelled not once but twice. During this coming year, we have ambitious plans for Jnetics. We want to continue to grow our annual Jnetics on Campus University programme, where we actually screen 250 students, increase the number of young couples who are being screened through our Jnetics clinic, and to re-establish our schools programme in the 9 mainstream Jewish secondary schools across the country, which has also suffered due to COVID. In addition, we have responsibility to screen 800 extra adults who were educated but not screened at school due to COVID. But to achieve our mission and responsibility to the wider community, we need to continue to raise vital funds. And this weekend, coincidentally, we will be launching a fantastic match funding campaign, which has been called Give and Let Live. This story really is the name. The more funds we raise, the more young adults we can screen, and the more lives we can save. It really is that simple. Is there a slide of the campaign, Gila? Oh, we've got notes as well. Okay, don't worry. So anyway, this is the campaign. It will be, hopefully you will see it all over the Jewish press. We have 150 ambassadors who are actually trying to raise vital funds for us during the course of the campaign. And we're trying to raise £500,000 quite simply so we can continue to screen and continue to save lives. So I have been given permission to ask if anybody is able to donate through this campaign. That would be absolutely amazing. And I believe that following this presentation, Aviva is actually going to send out the donation link. So together, we can all give and let live. Thank you. Okay. I just wanted to show, if I may, this short film, which is one of the campaign videos.
Born with cystic fibrosis, one of the almost 50 life-threatening genetic disorders across the UK Jewish community that Jnetics now test for. When Benjamin was born in 1978, it wasn't possible to discover if you were a carrier for any of these disorders. And Benjamin's diagnosis came as a complete shock to us. We were 2 very young parents. We had to struggle for years with hours of physiotherapy each day, food aids and supplements, intensive drug therapy, and a very different way of life from the one we had envisaged for our new family. When 23 years later, and after overcoming huge obstacles, Benjamin qualified as a doctor, he told me that we should concentrate not on a cure for cystic fibrosis, but on making sure no more children are born with not only CF, but any of the other, some even more terrible genetic disorders which affect our community. I promised that I would try. Benjamin died in 2005, aged just 26, leaving behind his new wife, his brother Jonathan, his parents, and the rest of our family. We were devastated and have mourned his loss every day for the past 16 years. So our family will never be the same again. Jonathan has no other siblings and now has to navigate his life as an only child. But you have it in your power to ensure your children and your grandchildren are born free from these disorders, so that never again will they or any other family in our community suffer as our family still does. The past 21 months have been hard in so many ways. COVID has had a huge impact on our fundraising activities, yet we have found innovative ways of continuing our mission of offering genetic testing to all those who need it, thereby enabling young couples to have children free of the disorders that we test for. But we need money to continue our essential life-saving work. And so we've launched this Give and Let Live match funding campaign. Our community has suffered great losses due to COVID, but by supporting Jnetics, there are deaths and broken lives that we can prevent. Please support our appeal And let's fulfill the promise I made to Benjamin to prevent young people being born and dying from these life-threatening genetic disorders. Please give and let them live. Thank you.
So I think you'll agree that's a very moving story. It's actually our chairman's wife, so who's obviously very invested in the charity. So anything you can do to help would be hugely appreciated. And thank you to all the wonderful speakers, and thank you for the time this evening. And thank you to Aviva for giving us this fantastic opportunity. We hugely appreciate it.